Congratulations on reaching the end of the introductory chapter of this course. Before moving forward, it is essential to consolidate everything you have learned so far and to understand how it connects to what lies ahead. This summary is not simply a review for its own sake. It is a structured reflection that will help you build a solid mental map of cybersecurity and DevSecOps, so that every concept you encounter next will fit into a coherent whole. Throughout this introduction, you have explored the foundational ideas that underpin both cybersecurity and the DevSecOps discipline. Let us walk through each major theme in a clear and purposeful way. The CIA triad, the heart of every security decision. Everything in cybersecurity starts with three fundamental properties: confidentiality, integrity, and availability. These three properties, collectively known as the CIA triad, serve as the reference framework for evaluating any risk or vulnerability. Confidentiality means that sensitive information is only accessible to those who are authorized to see it. A classic example is a user's password. It must never be visible to another user or to an unauthenticated attacker. Integrity means that data must not be altered without authorization. If an attacker can modify the content of a database record, for example, changing a bank transaction amount, integrity has been compromised. Availability means that systems and data must remain accessible to legitimate users when they need them. A distributed denial-of-service attack, which floods a server with requests until it becomes unavailable, is a direct attack on availability. Every vulnerability you will study, every test you will perform, and every correction you will apply can be analyzed through this lens. When you read a vulnerability report, ask yourself, which of these three properties is threatened? The OWASP Top 10, a prioritized map of web application risks. The Open Web Application Security Project, commonly referred to as OWASP, publishes a regularly updated list of the 10 most critical web application security risks. This list, known as the OWASP Top 10, is not exhaustive, but it reflects the vulnerabilities that are most frequently found and most damaging in real-world applications. Among the most important entries, you have studied broken access control, which occurs when users can access resources or perform actions beyond their intended permissions. For example, a regular user accessing an admin panel by simply modifying a URL parameter is a textbook case of broken access control. You have also studied injection vulnerabilities, particularly SQL injection, where an attacker inserts malicious code into an input field that is then executed by the database. Cross-site request forgery, another major category, tricks authenticated users into unknowingly performing actions on a web application, such as transferring funds or changing account settings, because the application cannot distinguish a legitimate request from a forged one. Authentication and session management failures represent another critical area. Weak passwords, improper session token handling, and the absence of multi-factor authentication all fall under this category. Understanding these categories gives you a prioritized map. When you approach a web or application security assessment, you know where to look first and why. Reading and writing vulnerability reports. A key practical skill you have developed is the ability to read a vulnerability report with comprehension and to write one with clarity. A vulnerability report is not just a list of problems, it is a structured document that communicates risk to both technical and non-technical audiences. A well-formed vulnerability report includes a clear description of the vulnerability, its location in the system, its severity level, often rated using the Common Vulnerability Scoring System, its potential impact expressed in terms of the CIA triad, the steps required to reproduce it, and recommended corrections. For example, if you discover that a web application accepts SQL queries through a search field without sanitizing inputs, your report should not simply say SQL injection found. It should specify the exact URL and parameter affected, demonstrate how an attacker could exploit it, for instance, by entering a payload such as a single quote followed by SQL commands to extract data, explain the potential business impact, data breach, unauthorized access to customer records, and propose concrete remediation steps such as using parameterized queries or prepared statements. This skill is fundamental because in a professional context, findings that cannot be communicated clearly are findings that will not be fixed. The DevSecOps philosophy, shifting security to the left. One of the most transformative ideas you have encountered is the DevSecOps philosophy, and more specifically the concept of shifting security to the left. In a traditional software development model, security testing happened at the end of the development cycle, just before deployment. This meant that vulnerabilities were discovered late, when they were expensive and difficult to fix. Shifting security to the left means integrating security checks as early as possible in the development process, ideally from the moment a developer writes a line of code. The pre-commit checklist you studied is a concrete example of this. Before code is even submitted to a repository, Automated checks can flag obvious security issues such as hard-coded passwords, insecure dependencies, or missing input validation. The counterpart to this is shifting right, which means extending security monitoring into production environments, observing real user behavior, and detecting anomalies that only appear under real-world conditions. Together, left and right shifts form a continuous security feedback loop. This feedback loop is crucial. When a vulnerability is discovered in production, the information flows back to the development team, who update their practices and automated tests to prevent the same flaw from reappearing. Security becomes a living, adaptive process rather than a one-time checkpoint. Pipelines and automated security testing. You have also worked directly with the concept of continuous integration and continuous delivery pipelines, which are automated workflows that build, test, and deploy software. Within these pipelines, you have learned to embed three categories of automated security tools. Static application security testing analyses source code without executing it, looking for patterns associated with known vulnerabilities. This is analogous to a spell checker for security. It catches problems early, at the code level. Dynamic application security testing works differently. It interacts with a running application, sending inputs and observing outputs to detect vulnerabilities that only appear at runtime. This is closer to how a real attacker would probe an application. Software composition analysis examines the third-party libraries and open-source components used by an application, flagging known vulnerabilities in those dependencies. This is increasingly important because modern applications rely heavily on external code. By placing these tools inside a pipeline, you ensure that every code change is automatically verified against security standards before it reaches users. The YAML mini pipeline you created during the workshop is a tangible demonstration of this principle. A structured configuration file that defines the sequence of build, test, and deploy steps, with commented security checkpoints at each stage. Connecting the concepts, a unified view. It is important to see how all these elements fit together. The CIA triad gives you the conceptual framework. The OWASP Top 10 gives you the practical map of risks. Vulnerability reports give you the language to communicate findings. DevSecOps and the shift-left philosophy give you the organizational and cultural approach. Automated testing tools embedded in pipelines give you the technical implementation. None of these elements works in isolation. A developer who understands the OWASP Top 10 but does not know how to communicate findings clearly is limited. A security engineer who can write excellent reports but does not understand pipeline automation is missing a critical skill in modern environments. The goal of this course is to make you fluent in all of these dimensions. What comes next? An opening to the following chapter. The next chapter will take you beyond conceptual foundations and into the practical world of penetration testing, also called ethical hacking or authorized security assessment. You will begin to learn how professionals actively probe systems for vulnerabilities, using structured methodologies and specialized tools. You will be introduced to the reconnaissance phase, which is the systematic process of gathering information about a target system before attempting any active testing. You will learn about tools such as Nmap, which is used to discover open ports and services on a network. And you will begin to understand how attackers think, because understanding the attacker's perspective is what makes a defender effective. The skills you have built in this introduction are not just prerequisites, they are the lens through which you will interpret everything you learn next. When you discover an open port during a reconnaissance exercise, you will think about what it means for the confidentiality, integrity, and availability of the system. When you find a potential injection point during a test, you will already know how to structure the finding in a report. When you embed a security check in a pipeline, you will understand why it matters in terms of the broader DevSecOps feedback loop. This continuity is intentional. The course is designed so that each new skill builds directly on what came before. You are not accumulating isolated pieces of knowledge, you are constructing a professional framework that will allow you to work as a cybersecurity and DevSecOps specialist in real environments, on real applications, with real stakes. Take a moment to review the key terms and concepts from this introduction before moving on. Make sure you can explain the CIA triad in your own words. Name at least 5 categories from the OWASP Top 10. Describe the difference between static application security testing and dynamic application security testing, and explain what it means to shift security to the left in a development pipeline. These are the building blocks of everything that follows.